Hi everyone, tonight we're going to talk about how energy is transferred in an ecosystem, which basically means we're going to be talking about food webs, hopefully as a review, and also about pyramids of energy. So, as I said, hopefully spoke about in class, food webs are a way of showing how energy is passed along in one particular ecosystem. So we might have one food web for an ocean and one food web for a forest and a different food web for a desert, all depending on the types of animals present in those ecosystems. And as I mentioned, when we talk about a food web, we're talking about how energy is transferred. So first of all, where does all the energy from Earth come from? That energy comes from the sun. And when we think about energy in an ecosystem, we want to know that energy is passed from one organism to the next, but also that energy can't be created or recycled. As a result, an ecosystem must have a constant source of energy. In order for an ecosystem to be considered stable, it must have a constant source of energy that is supplying the ecosystem with energy. In our case, planet Earth, our source of energy is the sun. You and I cannot use the sun's energy directly, but we know that producers or plants can use the sun's energy. So producers convert the sun's energy to a usable form of energy. Since producers are the ones that start off the energy transfer, they always need to be the first ones in a food chain. So as I wrote, producers must be the first organism in a food chain, since they are able to use the sun's energy and make it available to others. If we had a constant source of energy, but we didn't have a producer, we wouldn't get anything from that energy source. The only way we're able to use the sun's energy is by either eating plants or eating other animals that have eaten plants. And again, those plants have already converted the sun's energy. So when we draw a food web or a food chain and we have arrows in the food web or food chain, those arrows represent the transfer of energy. So we imagine we have a very small little food chain here involving a grass, a mouse, and a snake. And the sun is obviously the source of energy for this ecosystem. So we start our food chain with the grass, the producer. The energy from the grass is then passed to the mouse, and then the energy from the mouse is passed to the snake. So when the snake eats the mouse, what it's doing is getting the energy from the mouse. That's why the arrows point from the mouse to the snake. The arrows mean transfer of energy, not who eats whom. Here we have an example of a pretty common food web that you might see. A food web is in interrelated food chains. So we have our producer. We always have to have a producer in our food web. In this case, the producer is grass. What I'd like you to tell me is, what could one effect of increasing the population of lizards be? And what are two effects of decreasing the snake population? So one effect of increasing the lizard population, two effects of decreasing the snake population. On this slide, we have a very, very similar food web, only this time we also have the addition of decomposers into our food web. So let's see how this works. We start out with our producers, our trees and our grass. The trees and grass are then eaten by first-level consumers. Crickets, mice, deer. These are all herbivores. They only eat plants. And the herbivores are in turn eaten by carnivores or omnivores. And you'll notice that every single organism has an arrow leading away from it. Why is that? That's because when those organisms die, they will get broken down by decomposers and their nutrients will return to the soil. As I mentioned, when you have a food web, what's being represented is energy transfer. Now, if you think about it, if grass takes in 100 units of energy or 100 calories of energy and is then eaten by a mouse, not all those 100 calories of energy are going to be passed on to the mouse. Why is that? The grass itself needs the energy. The grass is going to do metabolism, it's going to do respiration and photosynthesis and excretion and all the life functions. And in order to do that, it needs to have energy. So when a mouse comes along to eat the grass, it only has 10% of that original stored energy available to it. And we call this the 10% rule. So as energy is passed along in a food chain, it is used up. Energy is used for metabolism. Energy is also released for heat. So as a result, only 10% of the energy that an organism gets is passed on to the next organism in the food chain. We call that the 10% rule, saying that as we go from one level to the next in a food chain or food web, only 10% of the available energy is passed on. And we can draw this or visualize this in a pyramid. We have our producer, grass, let's say, our primary producer getting energy from the sun. We're imagining this producer has 1,000 kilocalories of energy. Arrows coming off of the pyramid show us that 90% of the energy is lost as heat or from metabolism. So when we get to the next level of the energy pyramid, or the consumers come and eat the producers, they only get 10% of the 1,000 calories, which is 100 calories. And then the secondary consumer, in this case a snake coming to eat the rabbit, is only going to get 10% of those 100 calories, meaning 10 calories. And the third level consumer, the hawk, will also only get 10%, so there will only be 1 calorie of energy left for that hawk. Now this helps us also understand why you would have many fewer hawks in an ecosystem than rabbits. Rabbits have access to grass, and in that grass there's 100 calories of energy, let's say. So they have access to a lot of energy. Whereas by the time we get to the hawk, there's not much stored energy available for it. So it needs to eat a lot more in order to be able to live. So there simply would not be enough food to support a gigantic population of hawks. When we draw the energy pyramid, if you look back here, we drew it like a pyramid. We have producers, first level consumers, second level consumers, third level consumers. How does this pyramid work? First, producers are always found at the base of the pyramid. The base of the pyramid is the biggest part of the pyramid. It has the greatest stored area, and this represents the fact that the producers have the most stored energy. As you move up a level, the area of the pyramid decreases. This shows us that there's less energy available as you move along the food chain. The pyramid starts with producers, moves up to primary consumers, who are going to be your herbivores, then secondary consumers, and then tertiary consumers. That's the third level consumers. Pyramids do not usually have more than 4 to 5 levels, since there's just not enough energy at the top to support that many levels. When we talk about these pyramids, we can also think of a pyramid of biomass. Biomass would be the amount of living matter at any given level. So as the amount of available energy decreases from one level to the next, so does the actual number of organisms. So if we go back to our pyramid here, in this pyramid, there's 1,000 kilocalories of energy in the grass. And then as we get to the rabbit, there's only 100 kilocalories of energy. If we were talking about pyramid of biomass, we'd say maybe there's 1,000 grasses, but there would only be 100 rabbits. The number of the population goes down as well as we go up. We could see this pyramid here. Your most abundant species are the plants, then the herbivores, then the carnivores, and there's very few organisms left at the top. And in this diagram, if you pause your screen, you'll just see how a food web can be redrawn into an energy pyramid.